Almost every cloud platform offers a number of services related to containers and container orchestration. In this step, let's understand the need for containers and container orchestration. The journey towards container and container orchestration started with microservices. Microservices is one of the most popular buzzwords of the last few years. Almost every enterprise out there is heading towards microservices architecture. So what is a microservice architecture? The fundamental concept behind microservice architecture is, instead of building a large monolith application, how about building very, very small, independently deployable microservices? So microservices architecture is all about building small, focused microservices which are independently deployable. If you need to make a change to any of these services, all that you need to do is to change that service independently and deploy it. So if I would want to make a change to customer service, I'd need to just make change for the customer service alone and I can deploy it. The great thing about the microservices architecture is that it provides you with flexibility to innovate and build applications in different programming languages. If I had a monolith application, I can only make use of one programming language to build it. However, with microservices, you can use different programming languages to build your microservice. For example, I can build movie service in Go, I can build customer service in Python, I can build review service in Node.js, and I can build booking service in Java. However, as they say, with great flexibility comes great problems. One of the challenges with microservices architectures is the fact that deployments become very complex. The way you deploy and monitor a Go application might be different from how you deploy a Python application. And this might be different from how you deploy a Java or a Node.js application. So the job of your operations team becomes really difficult. They would need to have individual ways of deploying each of these applications, individual ways of monitoring each of these applications, and that makes their job really difficult. How can we have one way of deploying and monitoring Go, Java, Python, or JavaScript microservices? That's where containers come into picture. Docker is one of the most popular ways of building container images. What does Docker allow you to do? Docker allows you to create Docker images for each of these microservices. And your Docker image contains all the needs of a microservice. It contains the application runtime. For example, if you're building a Java microservice, you might need JDK. If you're building a Python microservice, you need Python. If you're building a Node.js microservice or a JavaScript microservice, you'd need Node.js. The Docker image also contains the application code and all the dependencies that the application needs to run. And therefore, you can run your Docker image the same way on any infrastructure. Because your Docker image has everything that a microservice needs, you can run it in your local machine, your corporate data center, or in the cloud the same way. In summary, a Docker image contains everything that your microservice needs. If you're building a Java microservice, it would contain Java, your application code, and the dependencies. If you're building a Python microservice, it would have Python, the Python code, and the dependencies for it. And therefore, you'd be able to take this Docker image and run it the same way on any infrastructure. So what are the advantages of going for Docker? Number one, Docker is cloud neutral. Whether you're making use of AWS, Azure, or Google Cloud, you can run your Docker image the same way. Docker also brings in standardization. The way you do deployment, monitoring, and logging, everything becomes the same. It does not matter what's inside a container image. It might be a Java application, a Python application, or a Node.js application. Your operations team does not worry about it. They would do deployment, monitoring, and logging the same way. In addition, Docker containers are lightweight. The alternative to Docker containers is to make use of something called virtual machines. In a virtual machine, we had guest OS, and the guest OS has a big performance impact. It used to consume a lot of CPU. Because Docker containers don't have a guest OS, they are lightweight. Docker also provides very good isolation for your containers. Even though multiple Docker containers can run on the same infrastructure, Docker can ensure that one container does not impact the other running containers. So it's almost like each container is running in its own box, in its own isolated environment. If I have to summarize all that Docker enables in one word, it is standardization. In this step, we talked about Docker and containers. I'll see you in the next step.